Hello students, in today's class we shall discuss the atomic mass unit, atomic mass, relative atomic mass, gram atomic mass along with the molecular masses also. In our previous class we have already discussed the Dalton's atomic theory. If you don't watch that video, please do watch and come to this video. Now let us begin the class now, that is atomic mass unit. Atomic mass unit, short form also known as the AMU. Let us see the definition of this atomic mass unit. It is equal to the 1/12th mass of an atom of C12 isotope. So if we clearly understand this particular definition, we can derive the value of the one atomic mass unit. So let us try to see an atom of C12 isotope. This we shall discuss 1/12th mass. First of all, let us see the an atom of C12 isotope mass means one single C12 isotope mass. So actually mass of C12 isotope is equals to 12 grams. So this 12 grams is not the mass of single atom of the C12 isotope. So 12 grams means it is the mass of 1 mole. That means Avogadro's number. So we can write down this one as 6.023 into 10 power 23 number of C12 isotope mass is equals to 12 grams. Then here they asked about the an atom of C12 isotope means single carbon 12 isotope masses. So then one C12 isotope mass equals to how much? So let's try to find out. So mass of one carbon 12 isotope is equals to do the cross multiplication. This 1 into 12 divided by this value. So 1 into 12 grams divided by 6.023 into 10 power 23. So this is the mass of one carbon 12 isotope. But what the atomic mass unit definition? It is a 1/12th mass of an atom of C12 isotope. Means in this value we have to take again 1/12th value. So now atomic mass unit that is AMU is equals to 1/12th of an atom of C12 isotope mass. An atom of C12 isotope mass is this much. This is 12 grams divided by 6.023 into 10 power 23. So 12 cancel out. So we get the 1 upon 6.023 into 10 power 23 grams. Or this can also be written as 1 upon Avogadro number of the grams. So this value is equals to 1.66056 into 10 power minus 24 grams. So that value is called as the how much? One atomic mass unit. Then this one atomic mass unit can be applied to both molecules and atoms. So here we can write down that AMU can be applied for both atoms and molecules. So when you are applying this for the atoms, there is no confusion because already the word atom is there, so we don't get confused much. But when you are going to apply the same AMU value for the molecules, then we get the confused whether it is we are discussing about the atoms or molecules. So to avoid that confusion, this AMU now replaced by unified mass, that is U. So we can write down that 1 AMU equals to 1 U. So U stands for the unified mass. Now let us discuss about the how to calculate the atomic mass. This is only atomic mass unit. So now let us see the atomic mass. So this particular atomic mass, it is always relative atomic mass. Whatever the atomic masses we are studying, they are not the pure values, they are always the relative masses. So what is the meaning of the relative masses? For example, if you take this particular marker, I don't know the mass of this marker initially, just imagine. So I will take another particular some measuring bar. So I call that measuring bar as 1 gram. So this marker now, I'll keep one side of the balance and the measuring bars on the other side. So I try to keep on the balance measuring bars on the other side. The moment the mass of this marker becomes equal to the number of measuring bars, then I call this one as the that much number. For example, if 10 bars I put, then these values are equal. Then I can call this one as the 10 grams because each measuring bar mass is 1 gram. So similarly here also for atoms, we cannot take the atoms into the balance, measuring balance. The reason is we know that atoms are very smaller in size and we cannot capture them properly. That is the reason why we have introduced the concept of atomic mass unit. So every mass of every atom is always related to the atomic mass unit. So after knowing the definition of atomic mass, then we will come back to the discussion, then how to understand the definition along with the examples. So atomic mass, it is equal to the mass of an atom of an element that is as many number of times as heavier than 1/12 mass of an atom of C12 isotope, or else in this place we can write down 1 atomic mass unit. That means if you take any atom, we are comparing the mass of that atom always with the atomic mass unit. That is the reason why these atomic masses are always called as the relative masses. So it is a relative mass. Then the question arises, so why carbon-12 isotope only has been selected? Its half-life is very high and it is more available, and apart from that, its value is always fixed as the 12 grams. It was fixed value, means they have considered the mass of a particular atom as a completely 12 grams. Then how this is called as relative mass and how to understand this particular definition. So it is equals to the mass of an atom of element as many number of times as heavier than the 1 atomic mass unit. Let us take an example here. So if hydrogen atomic mass, if you study as 1.008, that means hydrogen is 1.008 times heavier than 1 AMU. That's why hydrogen atomic mass single atom can be written as 1.008 AMU. Similarly, if you take the nitrogen, nitrogen mass is 14. That means it is 14 times heavier than 1 atomic mass unit. So its value for one atom can be written as 14 AMU. Oxygen, it is 16. That means it is 16 times heavier than 1 atomic mass unit. That means its value for one atom can be written as 16 AMU. So all this, not only this one, remaining all masses of atoms. So all the values are always compared with the 1 atomic mass unit. Whatever the number of times they are heavier than the 1 atomic mass unit, that was called as their atomic mass. If you take the helium, helium atomic mass is 4. That means helium is 4 times heavier than the 1 atomic mass unit. So how many times it is heavier than the 1 atomic mass is called as the mass of that particular atom. Then let us see the another definition of the atomic mass. It is also called as atomic mass. It is the sum of the mass of protons and neutrons present in the nucleus of an atom. So we know that protons and neutrons are called as the nucleus, simply number of nucleons. So atomic mass is equals to atomic number plus number of neutrons. Usually this calculation, number of protons plus number of neutrons, is applicable when atoms are in the motionless. So when they are not in the movement, then we can apply this particular concept. So let us see the average atomic mass now. So average atomic mass, if you see the masses of the atoms, for most of the atoms, the mass of the most of the atoms is not the whole number value, it is almost fractional values. For example, if you take the chlorine also, it is 35.5 grams we used to take. Then why the masses of atoms are not the whole numbers, why they are fractional in nature? Because most of the atoms in the nature, they exist as the isotopes. So we know that isotopes means atoms of the same element having the different mass number. So they are having the different masses, then we need to consider all of those. For example, let us take the chlorine. Chlorine in nature can exist as two forms, chlorine 35, chlorine 37. Chlorine 35 is available almost 75% in the nature, whereas chlorine 37 is available up to 25%. If we consider the mass of chlorine 35, then it could be the mass of chlorine could be only 35 grams. But you are neglecting almost 25% of the chlorine which is available in the nature. And if we consider this only chlorine 37, then its atomic mass could be, chlorine atomic mass can be called as the 37 grams. But in such cases, you are neglecting the majority percentage of the chlorine available in the nature. Then means we need to consider both of these values. So by considering this, we have to take the average, that is what called the average atomic mass. Then how to calculate the average atomic mass? Average atomic mass is equals to formula sigma xi mi divided by sigma xi, where x equals to percentage of the isotope of the element, whereas M equals to mass of the isotope of the element. Now let us try to calculate this value. Average atomic mass for the chlorine. So average atomic mass chlorine is equals to, let us take the percentage of every. Here percentage of the chlorine 35 is 75. Its mass is 35. Plus percentage of the next chlorine isotope is 25. Its mass is 37. Next, sum of the percentages. 75 plus 25 is equals to 100. Then this value is equals to, if we solve this value, we will get the 35.5 grams. So like this, after considering the isotopic masses also, we are getting the masses of the most of the atoms as the fractional values, but not the integer values. This is also not exactly 16, it is 15.995. So like that we are considering, we are getting, because we are considering the isotopic masses. And if you want to get the most of the atomic masses, they are available on the screen, you can see it. So now let us discuss the gram atomic mass. So next concept is gram atomic mass. It is also known as the gram atom. The definition of the gram atomic mass is, it is the mass of 1 mole of atoms. 1 mole of atoms means Avogadro number. Now let us see here example. Hydrogen atomic mass, single atomic mass is 1.008 AMU. Then what is the mass of the hydrogen for the 1 mole? That means gram atomic mass. So gram atomic mass of hydrogen is equals to, for 1 atom this is the mass, 1 mole means this value into 1 atomic mass, 1 mole. So here we can write down that 1.008 AMU into 1 mole. 1 mole value is 6.023 into 10 power 23. So let us write down this value, 1.008 into AMU means 1.66056 into 10 power minus 24 grams into 6.023 into 10 power 23. And this value can also be written as 1.008 into 1 upon 6.023 into 10 power 23 into 6.023 into 10 power 23 grams. This value cancel out. Final answer is coming again as same number 1.008 but in the grams. So here the atomic mass of 1 mole of atoms we are expressing here like this using the units again grams. Then the question arises, what is the difference between the atomic mass of the single atom and a gram atomic mass unit? Gram atoms. See, whenever you are using the AMU means this value is also present. So 1.008 into AMU means this entire value is for single atom. When you are cancelling this value with 1 mole, automatically you are getting the mass of the same atom for the 1 mole of atoms. So let us take example here. Hydrogen atomic mass 1.008. This value we can write down in the two formats. So 1.008 AMU or else 1.008 grams. So whenever you are mentioning the AMU, means you are discussing about the for one atom. So one atom atomic mass of hydrogen is 1.008 AMU, and whenever without AMU if you place grams, it is for 1 mole of atoms. 1 mole of atoms. Similar, let us take for nitrogen also. So nitrogen atomic mass we write down as 14. So 14 here again we can write down as 14 AMU and 14 grams. 14 AMU means it is for only one atom. Only one nitrogen atom. And 14 grams means it is for 1 mole of nitrogen atoms. So the value number, starting number is same, but the way we represent differs. Once you are using the AMU means we are discussing about the only one atom or single atom. But whenever you place the side only grams, that means we are discussing about the for 1 mole of the atoms. Usually for 1 mole of the atoms, the mass is called as the gram atomic mass. So here 1 gram atomic mass, 1 gram atomic mass or 1 gram atom. It is not the 1 gram atom means it is not the 1 gram. It is for 1 mole of the atom's mass in grams. If you write on the 2 gram atom, means it is about the 2 moles of the atomic masses in grams. That's why 1 gram atom is always equals to 1 mole. If 2 gram atoms means 2 moles, that means number of gram atoms equals to number of gram atoms equals to number of moles. So let us try to solve one simple question. Example, find the number of gram atoms in 54 grams of aluminum. Atomic mass of aluminum is mentioned as simply 27 without mentioning any type of the units, only number is mentioned. Then let us solve this one. 27 is the mass of 1 mole of atoms. Then means 54 grams is the mass of how many moles of atom? That is what number of gram atoms. So 1 gram atom mass of aluminum is equals to 27 grams. Then 54 grams is the mass of how many gram atoms? So number of gram atoms equals to cross multiplication. 54 grams divided by 27 grams, grams cancel out, it gives 2. That means number of gram atoms is equals to 2, means 2 moles indirectly. So now here, number of gram atoms formula we can write down as number of gram atoms is also known as the number of moles. So it's a formula we can write down as, what is the 54 here? It is a given mass. So given mass divided by, in the denominator we have taken the atomic mass. So given mass divided by atomic mass. For atoms, we can calculate the number of gram atoms using this formula. So number of gram atoms also known as the number of moles, given mass in the grams divided by atomic mass in the grams. Let us solve another simple question. So another example, find the mass of 4 gram atoms of silver. Silver atomic mass is mentioned as 108. So let us solve this one here. 108 means it is the 1 gram atom mass of the silver is 108 grams. Then 4 grams atom's mass how much? 4 into this value. So 1 gram atom mass of silver is equals to 108 grams. Then 4 grams mass, the mass of 4 gram atoms of silver is equals to 4 into 108 grams. This is the answer. So you can write down this one. This is 2, 3. So 32, 432 grams. We can solve the questions of the gram atomic mass using this type of the formulas also. Now let's try to calculate the molecular mass and gram molecule. So molecular mass. So molecular mass means it can be calculated for the single molecule and 1 mole of the molecule. Let us try to see for the single molecule first. It is the mass of a molecule which is as many number of times as heavier than 1 atomic mass unit. So for single molecule, this is the molecular mass. There is one more definition. It is the sum of the atomic masses of all the atoms present in a molecule. So let us discuss both of these definitions now. So first of all, let us take this value. First definition example. We know that water molecular mass, from this one we can also calculate it. 2 hydrogens are there, so 2 plus 1 oxygen is there, 16, that is equals to 18. If we write down 18 is the molecular mass of the water, it means that it is 18 times heavier than 1 atomic mass unit. So 1 molecule of the water mass can be written as 18 AMU. And if we take the carbon dioxide molecular mass, it is equals to 44. It means it is 44 times. It is 44 times heavier than 1 atomic mass unit. So here 1 carbon dioxide molecular mass we can write down as 44 AMU. Now let us try to use this particular definition. Already we have used it here. Again, let us try to use it. Then how to calculate the molecular mass of a molecule? Let us take some examples. If we take H2SO4, sum of the atomic masses. 2 hydrogens are there, each hydrogen mass, so let us take approximate value 1 plus sulfur 32 plus 4 oxygens, 4 into each oxygen 16. Then if you solve this, we get 98. Similarly, let us take N2O molecular mass. 2 nitrogens are there, 2 into 14, 28 plus here 16. So this is equals to 44. Let us take again H3PO4. 3 hydrogens are there, 3 into 1 plus 1 phosphorus 31 plus 4 oxygens 16. This value equals to 98. Now let us take in case of the hydrated compounds and anhydrous compounds. So let us take the hydrated compounds H2, C2O4 to H2O, oxalic acid dihydrate. So here oxalic acid dihydrate means we have to add these 2 water molecules mass also. Along with this particular molecule, we cannot neglect it. So 2 hydrogens, 2 into 1, 2 carbons, 2 into 12, and 4 oxygens, 4 into 16, plus 2 water molecules, 2 into 18. This value is equals to 120, 126 is the molecular mass. And if we calculate only H2C2O4, then 2 into 1 plus 2 into 12 plus 4 into 16 is equals to, it is giving 90. So for calculating the hydrated salts, we need to add the hydrated compounds, we need to add the water. For anhydrous compounds, not necessary to add the water. So when water is involved, automatically molecular mass changes. Now, let us calculate the gram molecular mass. Gram molecular mass or it is also known as the gram molecule. So, gram molecular mass means it is the mass of one mole of molecules. Expressed in the grams. Let us take the H2O again. 1 H2O molecular mass. 1 H2O mass is how much? 18 AMU we have taken. Then 1 mole of H2O 1 mole of H2O molecules mass is equals to 18 AMU into 1 mole. 1 mole means 6.023 into 10 power 23. So here 18 into AMU value 1 upon 6.023 into 10 power 23 grams into 6.023 into 10 power 23 cancel out. So again we are getting the 18 grams. So mass of the 1 mole of molecules, when you are expressing in terms of the grams, that is called the gram molecular mass or gram molecule. So 1 gram molecule, this 1 always stands for the number of moles. So 1 mole of the molecules mass in grams. If you are writing the 2 gram molecules, that means 2 moles of the molecules mass you are expressing in the grams. So number of gram molecules is equals to again number of moles. So here whenever they are asking, if you take this example, 18 is the molecular mass of the water. This 18, if we express as 18 AMU, that means it is for only one molecule. But if you express the same 18 in the form of the grams, that means it is for 1 mole of the molecules. Like that, carbon dioxide is there. Carbon dioxide 44 AMU means it is for only 1 carbon dioxide molecule mass. Instead of AMU, if you use 44 grams, that means it is the mass of the 1 mole of the carbon dioxide molecules. 1 mole means 6.023 into 10 power 20 the number of the molecules. So now let us try to solve one more question about the number of gram molecules. So as we discuss now, number of gram molecule is equals to number of moles. Take an example. Find the number of gram molecules present in 36 grams of H2O. So this we shall try to solve. So 1 gram molecule mass of H2O is equals to 18 grams. Then 36 grams is the mass of how many number of gram molecules? So number of gram molecules, that means number of moles is equals to 36 grams divided by 18 grams, cross multiplication. So grams cancel out, it goes 2 times, that means 2 gram molecules means 2 moles. So from this we can write down the number of gram molecules formula as number of gram molecules or number of moles. Formula we can write down as given mass divided by molecular mass. Given mass divided by molecular mass is called as the number of gram molecules or number of moles. For atoms we take the atomic mass here. For molecules we take the molecular mass. Now let us try to discuss about the formula mass. Formula mass. So this is applicable for the ionic compounds. Ionic compounds. Usually ionic compounds do not involve in the formation of the bonds, so they are called the formulas. So for them the mass is called the formula mass. But now and then we consider the formula mass as the molecular mass also. For example, let us take the NaCl, sodium chloride. Sodium ion, because sodium chloride exists as the Na++ Cl- ions. So sodium atomic mass is 23 grams. We don't take the ionic mass here because this charge do not influence the mass of the molecule or atom. That's why we take the atomic masses only. Since you are taking the atomic masses, this formula mass also can be called as the molecular masses. So 23 grams plus 35.5 grams, that is equals to 58.5 grams. Since it is applicable, means since there is no molecule bond in the ionic compounds, only formulas exist, ions exist. So for formulas the mass is called the formula masses, but now and then we can consider the formula mass as the molecular mass also. I hope you all understand this class. So if you have any doubts, please do write to the classroom@gmail.com. Thank you all.